Alright, problem 24. The expression 1 over 20 times the quantity e to the first plus e to the second plus e to the third plus so forth and so on to e to the plus e to the 20th is a Riemann sum approximation for one of the following here. And this is backwards from what we usually do, where we're going to have an integral and we break it down to the Riemann sum approximation. So it's going to be a little harder to see exactly what happens, but let's break this down a little bit and see a few things. The first thing I see is this 1/20th, which would distribute through to all of these terms. And we know that if we have a Riemann sum, we have basically the width of our rectangles multiplied by the height of the rectangles. So all of these are e to the x's. And so I have something that in some domain, some small zoomed in domain, is going to look like this, increasing. And what this 1/20th tells me, and I'm gonna draw this as a right Riemann sum, and we'll get back to that later, how I know that had to be the case. But what this 1/20th tells me is, first off, this width is 1/20th. And what this e to the 1, e to the 2, e to the 3 tells me is that this height is e to the x. Okay, so that should make a lot of sense. Now, the next part, I said that we were using a right Riemann sum, and actually it doesn't have to be that case depending on the function, but if I look at these, all of these x values up here end up as an x1, they end at e to the 20th. Except for this one right here, this is e to the 1 over 20th. It doesn't really match up, so this one won't be our case. This is e to the 400th, but other than that, the other ones all start at e to the 0, and actually they all start at e to the 0. But we don't include an e to the 0 here, so I can't use a left Riemann sum. But if I use a right Riemann sum, I start at e to the first for most of these, and then at e to the 20th. So I knew this had to be a right Riemann sum. Okay, so now we're looking at this, and let's basically just break down these and see what we get if we use a right Riemann sum. So this first one, the integral from 0 to 20 of e to the x, and let's use a right Riemann sum. This is going to be approximately, the first thing to notice is I want to use 20 terms, 20 subintervals, because I have e to the first all the way up to e to the 20th. And if I'm integrating from 0 to 20, each of the widths here is going to be 1. It's not the right answer. We do get 1 times, if we use the right, we do get an e to the first plus e to the second, all the way up to e to the 20th, like we're supposed to, except that we have this 1. So that's not the right answer. This one, well, I see a 1 over 20 here, so that might help out. Let's see what happens. So for the second one, I have this 1 divided by 20 in front, and then we look in here, and I still want 20 subintervals. And I'm going from 0 to 1, so the width of each of these is going to be 1 over 20 again, and we can see, I'm going to keep going a little bit, we do get our e to the first plus e to the second, all the way up to e to the 20th. But 1 over 20 times 1 over 20 is 1 over 400, not this 1/20th we have up here, so B isn't the case. This one right here, well, we do have our 0 to 1, 20 subintervals, we do have our 1 over 20. But unfortunately, if we use our right Riemann sum, when I start off putting in, this case would be 1/20th would be the first thing I put in. Let me just go to the last one. The last one's going to be e to the 1. I put in 1 for x, I get 1 over 20 here. the first one's actually going to be 1/20th divided by 20. The first one's actually going to be e to the 1 over 400. And we go all the way up to that e to the 1 over 20. So that doesn't match up. This one down here, well, this one's a big old mess, all sorts of wrong. And you can see we have the 1 over 20 here. That's good. I have 20 subintervals because I have 20 terms here, and I go from 0 to 20. So I don't have another 1 over 20. So far, so good. But the first value, when I go at the end of the first subinterval, when I put in the 1, I get e to the 20th. When I put in 2, I get e to the 40th. When I put in 3, I get e to the 60th, all the way up to, when I finally do put in 20, I get e to the 400th. Which, way off, way off. Okay, so e. Why is it e? Well, this one I have 20 subintervals. The total distance is 0 to 1. So I have 1/20th for the width of each subinterval. Like I had over in this diagram, that's good. And I look at this, so if I break it into 20 subintervals, my subintervals are 1/20th, 2/20th, 3/20th. I put those in, so the x values I'm going to use, x1, I'm not going to use x now, I'm not going to use the starting one because it's going to be a right Riemann sum. x1 is 1/20th. x2 I'm going to use is 2/20ths, 1/10, but I'll write 2/20th, so it cancels out nicely. And x, the last one, x sub 20, is going to be 20/20th. It's going to be equal to 1, but I'll write 20/20th, just because I like writing stuff. And so when I put this in, e to the 20 times 1 divided by 20, 1/20th, is going to be e to the first. Hey, that's good. E to the 2 over 20th times 20 is going to be e squared. Keep on going. Until I get to e to the 20 times 20/20th, so lots of 20s there, but we end up with an e to the 20th out of here, and it matches up. E is my correct answer.